Okay, so today's lesson is a continuation of yesterday. So yesterday we took notes about electron configurations. We talked about periods or the energy levels. We sort of compared the Bohr model to the Lewis structure, and we looked at electron configuration. Okay. Today we are going to just kind of add to that, and we're going to learn about Aufbau's principle. One part that we're going to add today is quantum numbers. So that's kind of really just a vocabulary word that we need for this unit, because you're already looking at them, you're already thinking about them. We just have to define what they are. Quantum numbers are the address for electrons. So we are going to talk about two quantum numbers today, and we will add some more as we go along. The first quantum number that we are going to talk about is N. N is the energy level. So you've already talked about energy levels. Okay, we could come back up to yesterday's work, what we had here. We could add to this line. Periods equal energy levels equals N. That's the first quantum number. So thinking about that, if we look at our periodic table, bring back in our periodic table, how many energy levels are there? If the periods are the energy levels, there are 7. 1, 2, 3, 4, 5, 6, 7, and that's the bottom of the periodic table. Because we know that the rare earth metals actually fit in to period 6 and period 7 right there. But in order for it to fit on a page, you have to pull them out. So we're looking at the energy levels, which are the periods from the periodic table. And then we are also going to look at the quantum number L. And that is the shape of the orbital that is being filled. So like the shape of the house that the electron lives in, or the letter. There is a lot to this. We could go deep, deep, deep like the ocean deep, but we are going to just kind of stick to the scope of our course for what we're looking at. And we'll look at those letters. Okay. We had S, P, D, and F that we talked about yesterday. Okay. An S orbital is a circle, so it's a sphere. A P, and it can hold how many electrons? We talked about that yesterday. Every S orbital can hold 2 electrons. Okay. P orbitals are kind of the dumbbell shape. And there is a x-axis, a y-axis, and a z-axis. So that 3-dimensional, I guess we could add 3D. 3D dumbbells. So thinking about that, if there are 3 of them and 2 electrons can fit in every orbital, we know that P can hold 6 electrons. Okay. D and F are really strange shapes. Okay. There are 5 different configurations for D and 7 for F. You need to be able to tell the dumbbell and the sphere for P and S. And then for the D orbital, we know that that can hold 10 electrons, and the F orbital can hold 14 electrons. Okay, this is going to come into play as we move on to writing electron configurations, and that's where we're moving today. We are going to look at these first 2 quantum numbers, and then we will add to that later. I'm going to give the Aufbau principle a whole new page. So I'd like for you to do the same. I'm going to flip that page over. And I'm going to flip that page over, and we're going to title this page the Aufbau principle, or the diagonal rule, which is what this is called. Aufbau is kind of a funny spelled word. Aufbau principle. It is the scientist who figured out this diagonal rule. Okay, so we're going to talk about the periodic table here in a second, but the word diagonal means like this, diagonal, or like this, but for our purposes, diagonal rule. Scientists are not always super creative with their titles. Diagonal tells you the pattern, and that's what this is. This is a pattern for filling electron orbitals. Orbitals are like the little houses the electrons live in. So let's look at a periodic table for just a second. Let's pull one in. I'm going to move the camera up so you can... Alright, we look at the periodic table here. Okay, so if we have our periodic table here, we're going to take a little tour of the periodic table. Start with 1. We're going to start in 1s. That's our first quantum number. The energy level, 1. And we're in the S block, 1s. We'd be in 1s, 2, because we have 2. Come back around. 2s, notice there's 2 spots there. An s orbital can hold 2 electrons. So 2s, then we keep traveling. We're going to go in 2p. Okay, keep traveling. 3s, 3p. So the organization of the periodic table really helps you out right there. 3p around. There's 4s, and then here's these transition metals. We talked about how they don't always behave as same as everybody else. Well, here's one example. This is 4s, but this is 3d. So 3d, 4p, 5s, 4d, 5p. Okay, then we got 6s. You've got 3, 4. Okay, so then we come up here, we have 6s, and then we're gonna pull out the 4f right here. This pulls out 4f, 5d, 6p, come back around, 7s, 5f down here where this pulls out. We're going to come back, pick up these rare earth metals that are down here at the bottom. Then we're going to go 6d and 7p. So traveling through the periodic table, we go through the blocks on the periodic table, and we can see where each electron would end up, where its address is. Alright, now Aufbau, the beauty of Aufbau is that he created a way for us not to have to travel through the periodic table every time. So here's what he did, and you can see this picture in your lesson as well. But he said, alright, if I travel 1s, 2s, the thing that he discovered was that we can write all of the s's, 5s, 6s, 7s, and then if you look at the periodic table, there isn't a 1p, but there is a 2p, so we're going to start with 2 here. 2p, 3p, 4p, 5p, 6p, 7p, because when we look at the periodic table, they knew that there was a 7p right here. 7p. Alright, and then the next letter is D. So, like we said here, the transition metals, we start with 3D. So we're going to go 3D, 4D, 5D, and 6D. Now you might say, well, why don't you have a 7D? Well, that's a great question. Let's look. If we look at D, 3D, 4D, 5D, 6D. There's only 4 rows in the D block. So there's only 4 energy levels shown on the D block, and that's what these numbers are, the energy levels. And then the same with the F block here. There's only 2. So we're going to jump down in our same pattern. 4F, 5F, there's only 2 rows. So that is where the beauty of Aufbau comes in. Then he realized that you just have to do diagonal rules, diagonal lines to follow the rule. So 1S fills first, and then 2S, then 2P and 3S. Okay, that all makes sense. And then 3P and 4S. Notice 4S fills before 3D. So then 3D, 4P, 5S, 4D, 5P, 6S, 4F, 5D, 6P, 7S, and then 5F, 6D, 7P in that pattern. So then the next thing you have to do is you have to know how many electrons you have and follow the pattern. It's pretty simple instructions. How many electrons do you have? Follow the pattern. To that number. Alright, so let's do some simple ones. Let's start with we'll just do hydrogen. If I look at the periodic table, hydrogen is number 1, so hydrogen has 1 electron. I'm going to start with 1s, and there's only 1 electron, so 1. Straightforward. Let's look at helium, which is number 2. Helium is number 2, so it has 2 electrons. I'm going to start with 1s every time. I'm going to say 1s. This time I have 2 electrons. An s orbital can hold 2 electrons, so I'm going to put a 2. I'll just keep going. Okay, lithium has 3 electrons. So I'm going to start with 1s. I'm going to say 1s, 2, but I have 1 more electron, so I'm going to follow the pattern. The next one is 2s. I only have 3 electrons, so 2, I only need 1 more. So 2, 3. There's my 3 electrons for lithium. Alright, let's do a little bit longer one. Let's do magnesium. If I look at the periodic table, magnesium is number 12, so it has 12 electrons. And so we're going to start at number 1s. 1s, 2. I'm going to follow the pattern because that's not enough electrons. I'm going to go 2s, 2, so I have 1, 2, 3, 4 electrons. It's not enough. 2p. Now, how many electrons can a p orbital hold? 6. So 4 and 6 is 10, but I need 12. So 1s, 2s, 2p, 3s, and I needed the 2 more. And that kind of makes sense when you look at magnesium. Not kind of, it does make sense. When you look at magnesium where it's at, magnesium is at the end of the S block in the 3rd period. So we should end magnesium at 3s2. It's in the 2nd column of the S block. That makes sense. Alright, let's do a bigger one and then we'll talk about noble gas configuration. Let's go ahead and do cadmium. It's number 48. We'll go through a lot of the letters this way. Alright, so we'll come down here at the bottom and we'll do cadmium, 48 electrons. Alright. So we start with 1s. And then we go 2s. That's only 4 electrons, so we're going to keep going to 2p. There's 10 electrons. 3s, so that's 12 electrons. Okay, so I'm going to go, after 3s, I'm going to fill 3p and 4s. And then I'm going to go 3d. How many electrons can d hold? 10. Now, do we need 10? Let's count again. There's 10, 11, 12, 18, 19, 20, yep. There's 30, so I need 18 more So I'm going to go 3D, 4P. There's 36, 5S, 38. I need 10 more. So I'm going to go 5S, 4D, and D can hold 10. So let's count them again, make sure we got it right. There's 2, 4, and 6 is 10, 11, 12, 18, 19, 20, 30, 36, 37, 38, 48, which is what we needed. Okay. Big, long dude. I don't want to write that much. You probably don't either. So here's the trick that we can do. When we look at cadmium right here, number 48, we can go back to the noble gas, which is before cadmium, which is the krypton, 36. We can kind of steal its pattern. What we do is we say, put krypton in a bracket, and we're going to say, we're going to use everything krypton's got, and then if we look at krypton, krypton is in 1, 2, 3, 4, 1, 2, 3, 4P. So at the end of 4P, then we would write the rest of that. We use everything krypton's got plus this stuff. Now this is way shorter. This is called noble gas configuration. It is a shortcut. Okay, so feel free to use the shortcut. Sometimes you'll be told that you're not allowed to use the shortcut. And if you wanted to start with noble gas configuration, let's do one starting with noble gas configuration. We will, let's just do zinc, okay? So we look at zinc. Zinc has 30 electrons. This is just me putting a note out for myself. You don't have to actually do that. And if I look at where zinc is on the periodic table, the noble gas before zinc is argon, which is 18. So I'm going to start with the argon. And I look at argon, I say it is in 1, 2, 3P is at the end of its row. So, and that's 18 electrons at the end of, it's hard to fit all that in. At the end of 3P, so the next one I'm going to have is 4S. So I'm just going to write that here. 4S can hold 2. So that's 18, 19, 20. And then according to Aufbau, I'm going to say what comes after 4S. Well, 3D comes after 4S. So I had 18, 19, 20. And that would be 10. That's my 30 electrons. And that makes sense. If we look at where zinc is at the very end of that D block. So it should be full. It should be 10. And it is. Okay? Alright, so that is the Aufbau principle.